Okay, so hello guys. Today we are. My name is Rutish. I'm from Vitwit Technologies, and today we are going to discuss about CosmWasm smart contract migration. Before we start about CosmWasm smart contract migration, we are going to first start about the basics, some of the basics of what are smart contracts and how we create them and what is the specific smart contracts we are using what in what blockchain and all. So yeah, the main first question is what are smart contracts? So a smart contract is a self-executing computer program that runs on a blockchain. It is a piece of code that automatically executes the terms of a predefined agreement as a contract when certain conditions are met. Which means that it's a piece of program which is self-executing. Once it can be run on a blockchain, and it is a far more secure and uh, useful application. And basically smart contracts have wide range of applications. They can be used for uh, decentralized finances to supply chain management and etc. Their main perks are automation and transparency, as anything anything on a blockchain can be viewed and tested by anyone on the blockchain. So it's transparent and mostly secure. So the second thing is a CosmWasm smart contract. Okay. So how to create a CosmWasm? So smart contracts in a CosmWasm are they have a particular perks rather than Ethereum and all. So what is that? We can say that a smart contract, CosmWasm smart contracts has many perks, like it is secure and it is fast and efficient, and it's also written in Rust, which in turn makes it a more secure smart contract. And yeah, it also has a capability to connect with different blockchains, as it is a part of IBC and Cosmos network. Yeah, and the next step is what are the different steps to deploy and run a contract. Okay, so how we write a CosmWasm smart contract is can be written in Rust by using a particular format. That is, we define the contract and we try to give instantiate it, and it has some particular execution, and it can also be migrated. So how we deploy is that for deploying a smart contract, we write the contract logic in Rust, as I said before, and we try to compile it in a WebAssembly, or also known as WASM. So for those, what we do is, so this is a particular example of a smart contract in a CosmWasm smart contract. There's a contract, there is a library and a state, which can messages and this. So here we can see that instantiate is a method to initiate the initiate or initialize the smart contract. It's a particular it gives the smart contract an initial state to depend on and then work itself on further transactions or queries. Okay, next there's execute, which takes over the transactions and queries, and then executes them. Okay. So as we can see, these are the transactions and queries of a smart contract. So these are particular transactions which we can use to make changes to the smart contract or control the smart contract. And these queries give us the data or required info about the smart contract. So a smart contract, okay, this is a basics of smart contract. So what is migration? We know that when a smart contract is compiled and deployed, it is initiated, and mostly the initiated after initiation it runs on its own automatically, and then until or unless the conditions are met for it to be shut down. Okay, but what if the smart contract we have initialized is not the one we want? Like we want to upgrade it, or it has some errors or bugs. It's not that the particular first piece of code is a perfect piece of code. So this is the one of the problems Ethereum faced in the starting. because the smart contracts are immutable. As they are once deployed onto the blockchain, there is particularly no way in the start for them to be changed or easily manipulated. So the problem is that the smart contract should be mutable, so that there can be further bug fixes or improvements or upgrades or state changes. So for that reason, the concept of migration is introduced. CosmWasm does this better. Okay. So migration is something in CosmWasm which requires an additional component known as admin. Okay, so admin is an address which has a particular command over the command over the contract to perform the act of migration. Basically, as I said, a smart contract without an admin is practically immutable and cannot be changed. So what admin does is, after when you instantiate a when you deploy a smart contract and instantiate with an admin, you can change the smart contract by two types. It is state migration, which is practically just changing the format of the old contract by some new variations, and it's an upgrade. Upgrade is a upgrade or upgrade migration. It can be said that in upgrade migration, okay, in upgrade migration we the contracts logic, the whole logic is can be changed, and then the total contract can be shifted into a new contract or swapped into it. So these are the particular changes. And we have covered the what is migration and why do we need it. Okay, this now let's look into how to migrate a smart contract. So as I've shown you, these are the particular transactions. You can see that after instantiate there is a migrate transaction function. We can use it to change the. You can see that what are the arguments required. So sorry, my bad. Yeah, you can see here that a migration requires the previous contract address and then the new contract which is deployed, and code of a new contract which is deployed but not yet instantiated, and then the whatever arguments we give when we want to migrate a contract. Okay, so let's try a migration on right now. Okay, as we can see that here this is a smart contract which I already deployed and instantiated into the WASM-D testnet. So here we can see if you want to migrate it, I will I will try to do that. So here we can see that these are the different uh, deployments of my code one, this empty contract. This one I have deployed it as a code one. So I will create a new I will deploy a new contract now, which we will use to migrate it. For that we'll get a code ID as file. This command is used to compile and compile the smart contract which is currently right now. And next we use the docker command. This docker command to compile and store the command and into it. And optimize it also optimizes the contract and then gives us a final put. Okay, now we have to store the contract into the database, into the blockchain. So for that, we use this here. What we are doing is we are storing the contract.wasm which we have created and into the chain and okay, it is a success. So okay, it's practically over. So we'll again try to list all the code. So here we can see that our new contract is deployed. We haven't yet instantiated it. So now we can migrate this code ID 5 contract into the code ID 1, which is the first one. So here as the migrate subcommand is there, we have using the migrate subcommand. This is the same as the first one. Sorry. It's actually that's the creator address. We for if we have to know the contract address of one particular contract for code ID, we have to do this. Guys, sorry for the delay. I actually migrated the code from from 1 to 4 and I forgot. Yeah. Yeah, we can now migrate that code from 4 to 5. I'll show you that. Oh, disaster. So here we can see that whatever the migrate is asking is a contract address which for which contract we are migrating right now and where it needs to go to. Okay, so right now we created a new deployed a new contract without any contract address, and now we will migrate the contract which is right now in 4 to code ID 1. So this is the contract address. So sorry. Here we have to give the admin, as only an admin can migrate it. Okay, it's a success. Now we can check if it's still in the. So there are no contracts right now in code 4. If you check in code 5, it's already migrated. So this is it with new changes. If we made any changes, this is the basic migration, and there are much more different types of migrations. Right now, what have done is it is a type of migration which does not require any like checks or validations like what is the contract name or contract version. So each and every contract has a something has a name and a version which defines whatever the contract migration or whenever the contract needs a migration. If it is immutable, if it is immutable, we don't need these parameters. But if you want it to be mutable, it's mandatory that we give it a name and a version such that it can whenever the contract is migrated, we know which version it is. And there's also another required mandatory function which is a set contract version, which sets the contract, which creates a contract version each time